Alright, what we're going to do here is a little bit of a practice final here. We're going to try to see how this works out for us. And we're going to jump into this thing like we were taking a final exam and our whole grade depended on it. Okay, so what we're going to do now is we're going to move forward to the first slide. If you pulled up this schematic, what would you most likely be working on? All right, I'm seeing the instrument panel cluster. Now I'm seeing the powertrain control module. All right, I'm seeing the powertrain control module up on the top right too. There's a little bit of reference voltage going to, what have we got down there on the bottom right? What is that component down there? Looks to me like if we were going to look at this the right way, we can figure it out if we just look at it. Look at the readings on those schematics. I mean on these. See what those readings are. And pay attention to all that. Now, what part of the vehicle, what would your work order be saying? All right, we're going to move on. I'll go back and do the answers when we're done. All right, what kind of sensor is this? Is this a thermistor, a reed switch, a single pole double throw, or a potentiometer? What's that question sound like to you? This one here, I want you to look at this one for just a minute. Let's see if we can adjust a little bit where we can get this thing in here better. Zoom down. All right, we're wanting to know how many volts and amps that we have right here. We want to know how many volts and amps we have right here. We want to know how many volts and amps we have here. How many volts and amps here. Each bulb pulls 1 amp. That's important information. Relay's closed, although, see right there, I actually changed the relay so it would be closed. And so the headlight switch is on. It has energized the relay. The relay has got voltage going through here to this little bus, and then it goes down to those bulbs. These illumination bulbs here each pull 1 amp, and that one there pulls 1 amp. We're just doing that to make the math easy, okay? Now you may have to pause the video here to think about this. I'm going to move on to the next one for time. Between which 2 points would you do a charging system voltage drop test? And you got 4 points to choose from there. D, C, B, or A. Alright, study that one for a minute and then we'll move on to the next one. What would the charging system do if you disconnected this connector C124? Alright, now you know when you turn on your key, you got voltage going through that charge indicator going down in here. Pay attention to that schematic and look at it very carefully and tell me what you think. You can pause it if you need to. What would the alternator do if you had a voltage drop of 2 volts at point C? I actually saw that one time when I was working in the field on a Ranger that was like a 98 model. So if you had a voltage drop at point C, not only do we want to know what would happen, we want to know why it would happen. Alright. If for some reason the 175 amp mega fuse blows, what will the alternator do? Alright. Watch that for a minute. Once again, on this slideshow, you can pause it if you need to. If somebody cut that yellow wire, what would the alternator do? And we'll talk about it a little more in a minute. You can pause it right now if you need to. Alright, so on this question, let's see if I can make sure you got the whole slide there for you, so you don't have anything hidden. Okay, the right headlamp and the right front side marker lamp are both dim. What is the most likely cause? The right front headlamp and the right front side marker lamp are both dim. What's the most likely cause? Think about it. Both low beam headlamps don't work, but the bulbs and the fuses have already been replaced. What's the most likely cause? Both low beam headlamps don't work, but the bulbs and fuses have already been replaced. Alright, these are your low beams right here. Alright. Okay, let's move on. Neither tail light works, neither marker lamp works, and the license plate light doesn't work. What should you do first? Alright, this is a study in looking at schematics and thinking clearly. Neither tail light works, neither marker lamp works, license plate light doesn't work. What should you do first? What do these symbols mean? Those little symbols right there, what do they mean? What are those? Don't you just love these fill in the blanks? Study the schematic. If you disconnect one of the power window motors, what should you find at both of these terminals? In other words, if I completely disconnected that power window motor so that both of those wires were sitting there and there was nothing connected to them, what should I read at both of those terminals? What are these symbols? Some of you probably know this already. What are these symbols? Alright. What is this? You seen that before? This is a tricky wiring schematic, isn't it? Alright. What is this? What is that component? Just release that to the least common denominator. On a vehicle with an automatic transmission in park, you remove fuse 24 and find power at one side of the fuse. What should you find at the opposite side of the fuse? Power, ground, or what? Alright, do you see fuse 24? There's fuse 24 right there. Alright. You got that? The blower motor on this vehicle works on every speed except high. What should be checked first and why? On a different vehicle, the blower works on speeds 2, 3, and 4, but not on speed 1. What's the most likely cause of that? And why? Technician A says an open ground circuit, has be a G201 being ground, would render the blower inoperative. Tech B says an open circuit at G401 would render the blower inoperative. That's 401 versus 201. Who's correct? A, B, or both, or neither? And look at there. Now we can go back to the beginning. And let's hit our slideshow again from beginning, and we'll see about giving you some answers now. On this right here, what I would be looking at, it's obvious that we've got fuel tank sending units here. And we've got a fuel gauge up here. And the PCM is basically where all that information goes. So we're going to be working on the fuel gauge. If you didn't put the fuel gauge, you got that wrong. What kind of sensor is this? Is this a thermistor, a reed switch, an SPDT? This is a potentiometer. This is like a throttle position sensor. The higher you go with that, the higher the voltage here is going to be. So you got 5 volts here, you got ground here. That's what low reference is, signal returns, what Ford used to call that. Okay, so the higher that goes, it's that basically you're measuring the motion of a component that way. Okay, at A, you're going to have how many volts? You're going to have 12 volts. All right, how many bulbs you got? You got 3 bulbs. So you got 12 volts and 3 amps. At B, you're going to have 12 volts and 1 amp. At C, you're going to have 1 amp but no voltage because that's a ground. In other words, you're always measuring with a ground for your reference, right? Okay. At D, you're going to have 2 amps and 12 volts. That wasn't particularly difficult. Between which 2 points would you do a charging system voltage drop test? Well, how does the what terminal does the power come out of to go to the battery, and how does it get there? It basically is going to leave B, and it's going to go all the way through that mega fuse and come back over here to A. So I'm going to go from here to here with the charging system operating, and I'm going to measure that with my meter to see what kind of voltage drop I have. You're allowed to have half a volt on the positive side and 1/10 of a volt on the negative side. Alright, and what would the charging system do if you disconnected that connector right there? Alright, here's the deal. When you switch on the key, the power, the voltage, it goes through that. They got a little resistor going around it just in case that bulb blows. It actually turns on the voltage regulator. It's really important that there's voltage there. And basically, you could, if you disconnect that, this light is not going to come on, but that regulator is not going to be turned on either because it can't get any voltage, right? And so the charging system won't work. You need to make sure that the alternator light or the battery light, charge indicator light, whatever it is on the vehicle, is working. That's really important. All right, the alternator here, if you had a voltage drop of 2 volts right there, what would happen at that particular point is you would wind up with an overcharging battery. So it would keep trying to find its 14.5 volt target, but because it was not reading true, see, it reads the voltage right here in that regulator. It also feeds the field. It would be enough to feed the field and keep it energized, but that regulator, in trying to bring that sense voltage up to the 14.5 volt target, I saw the charging system bringing the battery up to 18, 19 volts one time because it had dropped voltage at that connector right there because the pin was pushed back. So just keep that in mind. All right, if this 175 amp mega fuse blows, you're not going to have any power right here. And the alternator's not going to be able to charge anything. Even if everything else is working, the power's got nowhere to go. Somebody cuts that yellow wire, it's going to be the same thing as this. Now if you short this to ground, that light will be on all the time, but the regulator will never see any power and it won't charge that way either, but the charge indicator light will be on all the time. But cutting this wire would kill that, and it would also kill the alternator. Alright, let's look at this one for a minute. Right headlamp and the right front side marker lamp are both dim. Okay, what do they have in common? Alright, they both got G201. Now if you wanted to get really cocky about that, you could go from the ground side of the battery to that bulb right there, and you could do a voltage drop test and figure out what your deal was there. Alright, both low beam headlamps don't work. Alright, but the bulbs and fuses have already been replaced. Okay, so they've already put that fuse and they've already put that fuse in there. What do you think is going to be going on there? Alright, see, now is it likely to have 2 bad grounds? I mean, I guess it could have if somebody was jacking around with it. But I'm going to say this control block, that relay that's built into that control block, is going to be the problem there. Because that one, excuse me, let me see, make sure I'm telling you the truth. This one, I'm sorry, that relay that's built into the control block, that's likely to be what's going on there. Neither tail light works, neither marker lamp works, and the license plate light doesn't work. Okay, right tail light, left tail light. Alright, neither marker lamp works. That's G701 there. That's interesting. Neither marker lamp works. So what do you suppose is wrong right there? Okay, again, you're going to have this still going up here. Either that or a cut wire somewhere right here. But, look at this. You could also have a blown fuse. So I would go to the fuse first. Always go and check what's quick and easy first. You got me? Really important. Alright, these things right here are LEDs. When you see a symbol like that in a schematic, that's an LED. Alright, if you disconnect both of those, you might notice this right here, the rest position for those power window switches is ground. So if I unplug this motor down here, this power window motor, I ought to be ground on both of those. If I don't, the switch could be bad, this switch here, or that switch could be bad, or the wire would be broken between there somewhere. So it could be that switch. In other words, you could have a passenger side power window that wouldn't work because of a bad driver's side switch. And I've run into that before, and it'll throw you for a loop. So you ought to read ground on both of those. Now as you toggle the switch back and forth, it ought to switch from ground to power on first one and then the other. Alright. So, what are these symbols? Those symbols are transistors. You got it? That makes sense? Alright, so you got you got PNP and NPN transistors. We'll talk about that a little more later. What is that right there? You figured that out? That is a headlight switch. Some of the Asian cars, Toyotas and stuff, they would have a schematic that would have it so that whenever you're in the auto position, these two are connected but these two aren't. When you're in the tail light position, these two are connected. When you're headlight position, all three of those are connected. And it's also kind of interesting that the main body ECU is looking for a ground from each one of these wires, see? And so you might want to keep that in mind too. All right, that is what? That is a starter. That's a starter motor. And the solenoid, it's all drawn together like that. All right, on a vehicle with an automatic transmission in park, you remove fuse 24 and find power at one side of the fuse. All right, you got B plus there. What should be here? All right, if everything is like it ought to be, look where this is going now. You got to watch out for these alternate current paths. That ought to that ground should be going all the way through there and lighten that up. See, because that's right here. It goes here, goes down here. If you follow that, it's automatic transmission. Excuse me. I got two clutch pedal position switch. There's a jumper there. All right, and so we're going through that. We're in park, and as we follow that down through that, see, I can be confusing even if you're used to looking at it. But you ought to see a ground there one way or another if you're checking it with a regular test light. Now this blower motor works on every speed except high. Now this is on a Chevy pickup truck. What do you think about that? I used to plant a bug like this whenever I was teaching, and some of the students would just worry with it, and they try to put a blower relay on it and all that kind of stuff, or blower resistor. But what the deal is, if you pull that front HVAC fuse, look what's going on there. When you turn it all the way on high, what does it do? It energizes that relay, pulls that over, and that power is supposed to feed straight into that motor. If it's working on all these other 4 speeds, and everything's fine with those, then, you know, I have seen these things go bad, but the first place I'm going to go is check that fuse right there in the schematic, in the fuse panel. All right, on a different vehicle, the blower works on speeds 2, 3, and 4, but not on speed 1. What's the most likely cause of that? Remember now, it works on 2, 3, and 4. All right, so, but not on speed 1. I would say that this part of that blower resistor is burned out, because when you're on 2, it bypasses that. When you're on 3, it bypasses it. That's nice, isn't it? All right, will an open circuit at G201 render the blower inoperative? All right, if you got an open circuit here, is that relay going to close? No, it won't. All right, technician B says an open circuit at G401, that's its other ground over here, would render the blower inoperative. Who's right about that? All right, so what does this do? This is going to take that ground, and it's going to go to that blower motor, right? So if it can't feed a ground to the blower motor, if that ground or that ground is inoperative, then the blower motor wouldn't work. So both of those guys are right. Well, I hope you got a little something out of this, because I had a good time.